Welcome to video 1. This is Manivan and I will be teaching you organic chemistry. The organic molecule problem for today has the name 3-ethyl 1-hexyne. We will be answering 3 questions. First, draw the line angle structure of the molecule. Second, count the number of carbons and hydrogens to find the chemical formula. Lastly, write and balance a combustion reaction. Here we go. So, how do we start drawing the line angle structure for 3-ethyl 1-hexyne? First, let's work backwards. Take a look at the last part of the name. The prefix hex indicates that there are 6 carbons present in the longest carbon chain. Alright, start numbering the carbons as the backbone for the drawing. 1, 2, 3, 4, 5, 6 carbons. Then it's just connecting the dots. Now look at the suffix YNE. This means that the molecule is an alkyne, which has a triple bond. The number 1 in front of hexyne indicates that the location of the triple bond is at the first carbon. There we go. Draw 3 lines to indicate that it's a triple bond. Now look at the first part of the name. Ethyl implies that there is an ethyl group, which will have 2 carbons. The number 3 directs its location to the third carbon. Find the third carbon and finish the drawing. There it is. Here is the final drawing. Now, count the number of carbons and hydrogens to find the chemical formula for the molecule. From the drawing, you can calculate the number of carbons. Remember that carbons are usually found at the ends and vertices of the line. So there are 1, 2, 3, 4, 5, 6, 7, 8 carbons. Recall that carbons can only make 4 bonds, while hydrogen can only make 1 bond. With that in mind, start on the left side by the triple bond to count the hydrogens. Notice that there are 3 bonds at the first carbon that makes up the triple bond, so there can only be 1 hydrogen here. At the second carbon, there are 3 bonds coming from the triple bond on the left and 1 bond coming from the third carbon on the right. The second carbon maxed out on its bonding, so there's no room for any hydrogen. At the third carbon, a bond is coming from the left, the right, and from the ethyl group, so there's only 1 hydrogen bond here. At the fourth and fifth carbon, notice that there are 2 bonds, one coming from either side of the carbon. So there are 2 hydrogen bonds at each carbon. At the sixth carbon, there's only 1 bond attached to it. That gives us 3 hydrogen bonds here. Now, let's go back to the third carbon. Remember that an ethyl group has 2 carbons. Since there are 2 bonds at this carbon, there can only be 2 hydrogens here. At the last carbon, there is only 1 bond, so there's room for 3 hydrogens. In total, there are 14 hydrogens. The chemical formula comes out to be C8H14. Okay, let's write and balance the combustion reaction for the molecule. First, recollect that a combustion reaction is a reaction that reacts with molecular oxygen. In this case, our chemical formula C8H14 has carbon and hydrogen as reactants. Remember that if the reactant has carbon, the product produced will be CO2. If the reactant has hydrogen, water will be produced. So the general combustion equation will be C8H14 plus O2 yields CO2 plus H2O. Now let's balance the equation. First, balance out the carbons and hydrogens, then balance oxygen last. On the left side of the equation, the subscript 8 indicates that there are 8 carbons, and the 14 informs that there are 14 hydrogens. On the right side of the equation, there must be a coefficient of 8 in front of CO2 to get 8 carbons. To get 14, you need a coefficient of 7 in front of water, as 7 times the subscript 2 equals 14. Now let's count up the oxygens. The coefficient of 7 in front of H2O tells us we have 7 oxygens. The coefficient of 8 in front of CO2 must be multiplied by the subscript of 2 to get 16 oxygens. 16 plus 7 gives a total of 23 oxygens. Since 23 is an odd number on the right side, and the left side will give an even number because of the two molecules from the molecular oxygen, this will create an unbalanced equation. So we need to multiply all the coefficients on the left and right side of the equation by 2, or by doubling the current coefficients in order to balance this out. On the left side, 2 will be the coefficient in front of C8H14. Now 2 times the subscript of 8 will be 16 carbons. And 2 times the subscript of 14 equals 28 hydrogens. Let's move to the right side to balance the rest of the carbons and hydrogens. Multiplying 2 to the initial coefficient of 8 will now bring a new coefficient of 16 in front of CO2 to get 16 carbons. By the H2O molecule, the initial coefficient of 7 multiplied by 2 gives a new coefficient of 14. 14 multiplied by the subscript 2 equals 28 hydrogens. The coefficient of 14 indicates 14 oxygens. By the CO2 molecule, the coefficient of 16 multiplied by the subscript 2 will equal 32 oxygens. So when you add all the oxygens on the right side together, you have 32 plus 14 to get a total of 46 oxygens. Now let's balance the left side to have 46 oxygens as well. A coefficient of 23 multiplied by the subscript of 2 will give us 46 oxygens. Perfect. The number of molecules on both sides are equal. All right, we have a balanced combustion reaction equation of 2C8H14 plus 23O2 yields 16 CO2 plus 14 H2O. Well, that's it for today. You have learned how to tackle 3 problems regarding the organic molecule 3-ethyl 1-hexyne. Thank you so much for watching my video.